Alright, welcome in the session. So in this session we'll be revising some things, all the things in fact which we have learned in the module of probability for descriptive statistics, which lays a foundation for inferential statistics. Okay, we'll recap what all properties of probability we have studied in these videos. Okay, so the first thing that we have learned, we'll not go into detail in this video, it's just going to be a quick review or refresher of the concepts. The first thing that we have learned about probability is a random experiment is basically a thing or basically an occurrence which has any outcome. So it has any outcome. Okay, so like I can give rolling a die. Okay, I'm rolling a dice which will have obviously different possible outcomes. That is my random experiment. The second thing that we have learned about is a sample space. Sample space is total outcomes available in random experiment. Alright, all the possible outcomes. Like for example, in our rolling a die, let's call it a random experiment A. The different outcomes of A that we have can be 1, 2, 3, 4, 5 and 6. Okay, those are all the possible outcomes if you are rolling a die. So what are the total number of outcomes? The number of outcomes that we have in the sample space is going to be 6. I'm sorry, this is not A, this is S. Sample space is noted by S, and there are 6 possible outcomes that you have here. So 6 possible outcomes are there. Okay, the next thing that we have talked about is an event, and an event is a subset of sample space, the subset of a sample space. So for example, I'm rolling a die and my sample space is 1, 2, 3, 4, 5, 6. I define an event E1 which is a prime number. A prime number is obtained on rolling a die. So what will be my possibilities of the event? What are the prime numbers? 2, 3 and 5. And you know this is a subset of the larger set 1, 2, 3, 4, 5, 6. Okay, this is an event. I define another event is a number less than 5. So what are the possible outcomes here? 1, 2, 3 and 4. These are less than 5, and this is also a subset of the sample space. This is your sample space. So this is also a subset of your sample space. So this is an event. Okay. In events, we have talked about certain special categories also. The first type of event we have understood is disjoint events, which are also mutually exclusive. Okay, so what to be done in disjoint events and mutually exclusive? This means they have an intersection of 5. That means no common occurrence. They have an intersection of 5, which means intersection is phi only if there is nothing common between the two events. The occurrence of one event automatically cancels out the occurrence of another event. So in this particular case, let us define a first event as E1 is our odd number and E2 is an even number. So in even odd number 1, 3, 5 are the possible odd numbers in rolling of a die, and even numbers are 2, 4, 6. So you can already see there is nothing common in this. And obviously we can say if an odd number occurs on rolling a die, the even number obviously will not be occurring. Okay, if an even number occurs, obviously an odd number will not be occurring. So the intersection of E1 and E2 is phi. So these are mutually exclusive or disjoint events. I'm sorry, I think there's written something here, so we'll just shift the board here. Yeah, okay. The next set of events that we have understood the second set of events are exhaustive events. Exhaustive events are those events E1 union E2 whose union n times will give you the sample space. So if I club up all the events together, my whole sample space will get covered. So again, I define an event E1 as an odd number and event E2 as an even number. I will have the outcomes 1, 2, 1, 3 and 5 here, and I would have the outcomes 2, 4 and 6 here. If I take the unions, I will have the entire sample space covered. 1, 2, 3, 4, 5, 6. Union is just adding them up, which is equal to your sample space. So these two events E1 and E2 are exhaustive and mutually exclusive simultaneously. Okay. The next thing that we have understood is complement of events. So complement of events is, if I have an event A, my A complement is equal to the sample space minus A. So whatever is there in the sample space other than my event A will be A complement. All other possibilities in sample space. Okay. So for example, I define event E1 as 1 occurs. That means the only outcome here will be 1, because I'm writing 1 is the only number that occurs. So E1 complement will be S minus E1, all the other outcomes other than 1, which is 2, 3, 4, 5 and 6. These are all the other outcomes in the sample space other than 1, which is the complement. Even if I talk about these two, if an odd number is occurring and I talk about E1 complement of odd number, you will see this is even number, because this is simply your 1, 2, 3, 4, 5, 6, your sample space, minus your odd number. Subtraction of sets is just the elements which are not present in the initial set, which is going to be 2, 4, 6, which is your E2. So basically we can say E2 is E1 complement, or E1 is E2 complement in this case as well. Okay, fine. So this we have understood. So complementary of events. Okay, then the next thing that we have learned is the addition rule. The addition rule that we have understood. Okay, wait. The next thing that we have understood are probability formulas. Okay. Probabilities formulas. So the first thing we have understood is probability P of an event is basically the number of favorable outcomes that we are asking about by all the outcomes, which is your sample space. So for example, I have to find the probability of event E1, which is P E1. I have to find out, and E1 is odd number. So what is the probability of odd number and rolling of a die? So what are the favorable outcomes? 1, 2 and 1, 3 and 5 are my favorable outcomes. And what are the total number of outcomes, which is sample space? 1, 2, 3, 4, 5, 6. So the number of outcomes here is 3. Number of outcomes here is 6. So your probability is 1 by 2. Okay, this is 0.5 is my probability. Number of favorable outcomes that we are demanding divided by the sample space. Now there are certain axioms of probability that are also there. The first axiom of probability is probability values will lie between 0 and 1. It can be 0, it can be 1, but it cannot be greater than 1. Greater than 1 and less than 0. Okay, if the probability of an event is 1, if PE is 1, that means the number of elements in E is equal to the sample space. So that's basically my probability of sample space. So this concludes probability of sample space is 1. Okay, because P is 1. So P is 1 only if the favorable outcomes is equal to the sample space is 1. That means the favorable outcomes is equal to the sample space. So the number of outcomes, if it is equal to the sample space, I will get the probability as 1. Probability of 0 will happen if the event is a null event. That means there are no favorable outcomes. No favorable outcomes in sample space. If there are no favorable outcomes in sample space, then my probability of that particular event will be 0. So for example, I define an event E1 in a rolling of a die as a number greater than 10. This is my event. But my sample space you already know has only these outcomes 1, 2, 3, 4, 5, 6. Is there any number greater than 10? So no, there is no number greater than 10. So this is going to be 0. 0 by 6, which is 0. There is no favorable outcome. So when the event does not exist only in the sample space, the probability of that event is 0. When the probability of sample space is taken, it is 1. Rest all the events have probability between 0 and 1. And then second we have taken is if there are multiple exhaustive events, if E1 and E2 are exhaustive, then what we have understood is PE1 plus PE2. Okay, if there are n events, then of course it PEN also, but here we are just taking 2 for simplicity. Summation of these two events will give you 1. Okay, because if they are exhaustive, you know, if you'll add them up to become the sample space, and if you just add the probability, it's basically the sample space by sample space, which is going to be 1. Okay, and then we have learned about the addition rule of the events as well, which is P of A union B is PA plus PB minus PA intersection B. Okay, so this is basically using your set theory, the law of set theory which we have learned. You will apply that at probability as well. Okay, probability of a union means the OR condition A or B is equal to probability of A plus probability of B minus probability of PA intersection B, which is basically A and B. A intersection B is A and B, which is the common elements between A and B. Now this rule gets a little modified. In terms of disjoint or mutually exclusive events. So if my events are disjoint, then you know that A intersection B is phi. So that means P A intersection B will also be phi, which for probabilities there cannot be a phi possible here, so we write it as 0. Because phi means nothing exists. Okay, so in terms of probability, we take nothing exists as 0. So P A intersection B is 0. So what is P A union B going to be in that case? P A plus PB only. Okay, this is only for my disjoint events. Then fourth one is probability values. Your probability, the first thing that we have learned is it is going to be 0 and 1. It can be a fraction, it can be a decimal, like this it is possible. It cannot be negative because obviously it cannot be less than 0. It can be as a percentage also. And finally, PA complement, probability of complement, and you already know A complement is S minus A. So P of S minus A, we can take it as PS minus PA, and you already know the probability of sample space is 1. We have already done this. This is 1 minus PA. Okay. So if you have to take the probability of A complement, PA complement is 1 minus PA. This is very, very important as a rule. A complement in terms of sets, it is A complement. In English, it is interpreted as P not A. Okay, not A. So if not A is also written, then also you treat it as A complement, and the probability of that is 1 minus PA. Okay, so that completes our basic probability that we have learned in, so far. We'll continue from conditional probability in our upcoming video. Thanks.